Hello boys and girls, welcome to another episode of FoulkesBrau. Today is Friday the 27th of March 2020. It's officially the first day of our lockdown, in case you're living in God knows where you'd be living to escape this, but the world is being overrun with COVID-19. Just on the news a couple of minutes ago, so it'll be the 9 o'clock news this morning, South Africa has now over 1,000 cases of this. We've had our first 2 fatalities, our first 2 deaths. It's a normal day for me. Our company's put us to work from home, and it's just been a normal day. I woke up normal time, 4 o'clock this morning, like I would normally do on a work day, and out of morbid curiosity I put the radio on, and the utter stupidity that is going on, people camping outside shebeens, flocking to the malls, going shopping, the taxi drivers that are now charging double rates. Guys, this thing is going to kill you. There is no two ways about it. You need to stay in isolation, stay the hell away from people. It's that simple. I'm not a medical doctor, I'm an engineer. There's a huge difference. From what I understand and what I've read, it's not the virus that is so deadly, it is how quickly it spreads, and the infection rate that is the killer, because you just can't treat all the people. My goal during this 21-day shutdown period, well, we know it's a minimum of 21 days, is to bring you some entertainment, and only way I know is either music or electronics. I just want to iterate, this is a very serious thing. Guys, we have high density population areas in South Africa. This thing will spread like wildfire. Yesterday morning we were sitting just under, if I remember correctly, it was 500 something. Yesterday afternoon was 700 something cases. Today it's over 1,000. This thing is growing almost exponentially. We've had our first 2 fatalities, so stay home. Watch YouTube, watch Netflix, whatever. Just rather stay home. Anyway, today I thought we'd have a look at a microwave. It's not my favorite piece of equipment to work on. You'll soon see why. It seems to be quite a thing that fails quite a lot in people's houses, and there's not really much to a microwave. It's not a complex instrument. The thing is, you need the right test equipment to work on a microwave. I'm going to show you how to check certain things in a microwave without having some very complex equipment, and then I'm going to show you using some high voltage probes and things like that, why you shouldn't be digging around in a microwave. Anyway, let's get it on the bench, let's get it open, and we will readjust the shot and take it from there. Right, so here we have our microwave on the bench. I've taken the cover off and I've turned it around to the circuitry side, because that's really what we are interested in. Notice the power cord is out. It's not plugged in. And we'll get to why you really don't want that plugged in as we go along. This microwave hasn't been plugged in for quite some time, and that's quite important. What we can see up here on the top right hand, our mains comes in. It goes through a fuse, safety capacitor for filtering, an inductor, nice little choke. That looks like some metal mobs there, metal oxide varistors for surge protection. We've got a little lamp up here, temperature sensor up here. It goes through to this control board, and that's where you set your timer, your different cooking programs and whatever. The real snot with this thing starts if you look here. In here there's a limit switch, and down here there's a limit switch, and then down here is a limit switch. They just cut off your mains to this side of the circuit. So normally when you have a microwave, normally what goes is these limit switches will bugger out due to wear and tear, and what will happen, it will blow. If you can see in there, that fuse in there, this microwave, the fuse is fine, there's nothing wrong there. The owner tells me that it doesn't heat up enough. So with just a simple multimeter, there's many checks we can do. Okay, first obviously you don't want the mains plugged in, and you want to leave it to stand. Down in here on the bottom right, you can see there's a huge capacitor, and over here is a little diode. This capacitor and diode, they act as a voltage doubler circuit, and we'll get to that. What it does is it's used to heat up in the magnetron, basically the plate. We'll get to that now. So really what happens is your mains goes through, you've got your little control board here, and then we have our high voltage transformer. This transformer will take your 230 volt mains in South Africa, and on that side 230 volts, and step it up to 2000 volts on that side. The voltage doubler here will now power the plate of the magnetron. It's going, on this side of it, it's going to be a negative voltage. So if we had 2000 volts, we're going to have a negative 4000 volts. That's 4000 volts for kilovolts. It's going to be a chopped waveform, and it's going to be a negative waveform, and that's how basically this capacitor and diode work. There's a lot of videos on YouTube on how voltage doublers work, so you can just look it up. Now, to cut to the chase, if it's not heating as the client suspects, it's not heating as quickly as it should be, the chances of being the high voltage transformer are not good. The chances of being the magnetron are not good. It could be the seals in this chamber where it passes the microwaves through to the oven, although I doubt that. More likely than not, it's going to be this capacitor. If this diode had failed, the fuse would have blown. If the capacitor has failed, in other words it's a short, again the fuse would blow. The same with the high voltage transformer, the same with the magnetron. If the magnetron was gone, it wouldn't heat up at all. So I suspect it's the capacitor, but before we even go there, let's show you with a common, just a common multimeter and normal probes. I'm not putting high voltage probes on because I haven't got any power on this. How we can go about checking these various components and then isolate it, and then at the end I will show you how we could just do under power, but I wouldn't advise you to do that. You need high voltage probes, you need to know what you're doing, and you can hurt yourself. A word of caution, this capacitor down here, as you know, a capacitor stores charge and it holds it. These capacitors have a discharge resistor built in. You cannot rely on that. It's really not advisable. So what I would advise you to do, if you're going to work on something like that, is get yourself some basically some clamps. You clamp it on basically onto here. Make sure that your chassis is connected to earth, and take a lead from here and short out that capacitor, both sides. Just hold it on there. Let's see if we got a lead here. We'll just clamp it in here. Of course this is not plugged into mains and it's not plugged into earth, but to give you the idea, I'm doing something like that. So you can see the lead is complete, and it would keep the capacitor from charging, because if you do go and put your hands in there, you're going to get a nasty shock, and it could kill you. Like I say, you can have 4,000 volts at that point. The other thing to be, you'll notice that we've got two windings coming off here, off the magnetron. The other side of it is for the this little red wire is for the filament of the magnetron. It's like a heater inside it. The thing with the magnetron is it works like a tube. So those of you familiar with not solid state electronics, very old electronics where you have tube amplifiers and things like that, vacuum tube amplifiers, the magnetron works the same way. So let's get it set up, and I will bring the multimeter in and we can measure out this high voltage transformer, see if it's okay. We can measure out the magnetron, we can measure out the capacitor, and we can measure out the diode, and we'll see which one is faulty. Right, so here we are. The first thing I'm going to do, remember this thing is dead. I'm going to set my multimeter to resistance, to ohm scale. I'm just going to put it on the first side of the primary, and I'm going to put the next lead on the second side of the primary, and I'm going to measure the resistance of the winding. 2.1 ohms, that is fine. It should be that low. If I take either winding down, I measure to the case of the transformer or the chassis, it should be open circuit, and I'm going to do that with both sides. So that tells me the primary side of that transformer is fine. We do the same thing on the secondary side, except we need to take out these wires on the capacitor and the diode and whatever. So I'm just going to unplug them. We'll measure the secondary side and see what we get there. Of course, if you're scared like me, and I have a very healthy respect for high voltage. You notice I'm using my long nose pliers just to pull these wires out, because I really don't want to be touching things, even though I know it's safe and I know it's off. So what I'll do is I'll just pull this out, and we can now see, is that yes, that is our secondary side. We can measure the secondary side of our high voltage transformer, and we can measure the magnetron, and we can measure this capacitor. So let's just get that set up. Right, so we're back. Let's try and get the multimeter in the shot. So I'm just going to prop it in there for you guys so you can see it. We're going to measure our secondary winding. We'll measure it to earth, and we're measuring 148 ohms. It's a little bit low. According to the LG service manual, 100 to 200 ohms, so it's mid-range, it's fine. Again, I'm just taking it there, and I'm taking it to the chassis. 150, 148 ohms. Okay, no problem. Next thing we want to do, obviously, is measure the filament for this thing. To ground, nothing. Great. To ground, nothing. And between the two, 0.3 ohms. That's perfect. Okay, excellent. Our primary and secondary side of our high voltage transformer is fine. If I go and measure now the magnetron, I'm just measuring across the two terminals, 0.3 ohms, perfect. If I measure either terminal to the case or to ground, let's show you where we're measuring ground, which is the same as the case. It should be open, and again, open. Perfect. So our magnetron is fine. Our high voltage transformer is fine. The only other thing that we've got in here is the capacitor. Now, you need to test capacitors. You ideally need a very nice fancy LCR meter like that. I'm going to do it with a multimeter just to see And what we'll do is we'll take it out and check it. Or we don't need to take it out, we can check it with the LCR meter as well in circuit. So I'm just going to set the shot up for that. I'm just going to unplug this diode. Well, we can do it while we're here. Let's see, come on. Oh, there you go, you're out. Okay, I'll take my shorting lead off. Now, what you can't do is set your multimeter to measure capacitance, because it just won't. Not this one. So what you would do is you'd set it to resistance, put it across the two terminals, and what we should see is the resistance growing. So it's charging. Okay. Now we could go from a terminal to the case, it should be open. Terminal to the case, it should be open. Again, we check this. You see how resistance is growing. Out of curiosity, I'm going to switch it to capacitance. And we're reading 980 nano. I'm not sure what the capacitance rating is of that capacitor, but what we'll do is we'll take it out and we'll have a look and we'll test it with our LCR meter, and we'll get a good idea from there what is going on. So let me take it out and we'll come back to that. Alright, so we've taken the capacitor out. As we can see, it's a 0.92 microfarad 2100 volt capacitor, rated capacitor, and we can see in the little circuit down here it shows us it's got a 10 mega ohm resistor in parallel with the capacitor. That's our discharge capacitor. Again, like I say, the multimeter is not the right way to do this. We'll use the LCR meter in a bit. I'm just going to take it and measure across these two pins 0.986 nanofarad, 0.986 nanofarad, and this is rated, oh sorry, that's 986 nanofarad, and this is rated 0.92 microfarad, so 920 nanofarad is what it's rated. Obviously this thing has got a tolerance and it's plus minus 3%, so it seems like it's intolerant, but this is the wrong meter to do this with. So what I'm going to do, I'm just going to move my multimeter out the shot, and what we will do is put in place our LCR meter. And why you want to do this is because I can set the frequency of the LCR meter. So I'm just going to clip it on, and we're going to set it to a frequency of, surprise surprise, 120 Hertz. Why 120? Well, in the States your line frequency is 60 Hertz. You rectify that, you will have 120 Hertz. So if we now go and look at the capacitance, we can see it's 929 nanofarad, so it's 0.92 microfarad. And what is interesting, I want to just look for the let's do this. The dissipation factor is 0.009. I did find a data sheet on that specific capacitor. That capacitor, typically they say the dissipation factor must be less than 0.01, so we are actually okay. So that capacitor is fine. So my suspicions of that capacitor unfounded. So far we know the high voltage transformer is fine, the magnetron is fine, the capacitor is fine. The only thing left to check is the diode. So I'm going to take the diode out, set it up, and we'll come back to that. Right, so we're back. I've taken the diode out. What I've done is I've switched my multimeter to diode test mode, and what you'll see is if I put the two leads, let's just put one, we'll put the negative on the cathode, we'll put the positive to the anode, and you'll see no reading. And if I swap it around, again, no reading. Why? This multimeter cannot generate enough forward voltage to switch the diode on. So one thing you could do is put your negative probe on the cathode on the band side, put your positive on the anode, and you'll see the resistance change. Again, you could swap it around, and this time we should have infinite resistance, which we do. A better way of checking it is rather to use a bench power supply, which I've done, so I'm going to just take that into the shot and we can show you that and how to test it that way. Right, so here we have my bench power supply set up. I've just got two leads. I've set the voltage to 12 volts. I've set the current limit to 200 milliamps or 0.2 amps. So what I'm going to do, we're going to take the negative lead of the power supply like that. We'll connect it to the anode. We'll take the positive lead and connect it to the cathode. What you can see, nothing. We've still got our voltage, no current flowing, perfect. So the diode is blocking it when it's reversed. If we swap it around, we switch the negative lead to the cathode, positive lead to the anode, we can see the voltage dropped. We've got 200 milliamp of current flowing. Obviously we've limited to 200, so the diode is fine. I'm going to switch the output off there. It's got quite warm. You can see it's quite a large component for the high power, and yes, trust me, it did get warm. So in fact, there is nothing wrong with this microwave. The magnetron is tested fine. High voltage transformer is tested fine. The voltage doubler circuit consisting of the capacitor and diode is tested fine. I'm just going to set up the next shot and show you why I don't actually like working on these devices. So let's get it done and we'll come back to that. Right, we're back, and as you can see I've got this nasty looking device here. It is a high voltage probe. It can measure up to 40,000 volt DC or 28,000 volt RMS, AC RMS. Notice it is a Cat 1 instrument, so you really do not want to be plugging this thing anywhere where you don't have an isolation transformer to get you away from your power provider. So for something like this, to measure in here, it's fine. I'm behind the mains high voltage transformer here. That's good. It's actually isolating us, and of particular interest, it's a 1000 to 1. So whatever I'm going to read on the multimeter, we would multiply that by 1000. So what I've done, you can see the positive and negative of this whole thing plug into here, and then there's an earth lead that goes to the chassis in this case, because the chassis is earthed at the top here. So the chassis goes back to my mains earth. I'm going to plug it in and we'll start it. Of course, I do have a glass of water in the microwave. It's not empty. So remember, I said this voltage doubler is going to make from 2000 volts on this side, we're going to get about 4000 volts on the other side. So I'm going to put my probe in there and we'll start it and we'll see what we read. There we go, 4000 volts. Remember, we were reading 3 there, times by 1000, that is your 4000 volts. And notice, times how much voltage we still got there as it's discharging. So even though it has got a discharge resistor, and remember I told you it would be a negative voltage on that side because that's what we're doing with the voltage doubler in this case, that is still will give you a nasty bite. If we go and we measure the primary side of the transformer, the primary side of the cap, the secondary side of the transformer, let's get in there. We're not reading anything. Go to AC, 2600 volts AC. Okay, so like I've said to you, this can hurt the hell out of you. Okay, that side's gone, and this side is still discharging. So if you have one of these and you know what you're doing, the quickest way to check it obviously is just to measure, and you don't have to go through all this rigmarole. But not many people, well, you guys aren't going to be carrying this sort of stuff at home. So I just thought I'd show you how to check it if you only have a common multimeter. Be very careful with these things before you use it. Really, there's a lot of inspection that goes on. You want to make sure that there's no cracks, nothing cracked in here, because this insulation is what's keeping you away from the trouble. All it is a voltage divider inside here. Again, if you're going to work on these things, you would normally have the right equipment. So our microwave, I'm convinced nothing is wrong with it. I just think maybe they woke up one day and for whatever reason decided it wasn't working. It could be because I know that somebody else opened this before me, and it could be that he actually fixed whatever was wrong in here, but the owner got impatient with him and just took it back. That might be as well, but now I've given you an idea how to check the high voltage transformer, the magnetron, the voltage doubler circuit of the capacitor and the diode. Right, we'll set it up and we'll end this video. Alright guys, that brings us to the end of another video. Microwave, very simple thing, very easy. Now hopefully you know how to check inside it if you ever have to fix something like that. And also now you know why I don't like probing around in something like that. You need the right equipment. Be aware that you have very high voltages inside it. It can kill you, it can be lethal. I've been listening to the news in the background. I'm listening to Talk Radio 702. I actually like Talk Radio. And guys, stay at home. There's no point in hanging around in malls or shops or things like that. You have to be mature about this and be responsible about this. You get this virus, you take it home, you kill off your loved ones. That's just stupidity. I'm going to try and shoot a video a day with little things like that. We've got some design stuff that I need to fix or finish, and some very interesting circuits there. I'm also I've got quite a bit of work that I do in my professional career my professional life that needs to be done, which is quite interesting. Some control system stuff that we need to set up and write some code for that, and quite interesting stuff coming up there. So until the next video, take care, stay at home, and watch YouTube, watch Netflix, tune in to this channel, I don't know. As always, if you liked it, give us a thumbs up and subscribe. Cheers.